gonna have lunch.
There you go. We're live. Great. Let's turn off this music. Pause. Get some comments going. Hi, everybody. Wait, we gotta get there's the one. Our guest of honor. I hope people can hear. I don't know. Let's see. Would you let us know, people, if you can hear us? Just like, hi from Devnexus.
Both of us. If you can't hear us, then we need to do something.
Well, they only need to hear you. Like, I add very little to the conversation. I'm just glad to have you here. It's rare. It's a treat to have you here.
It's an honor to be part of the show. Thank you so much.
Oh yeah, look, thank you.
Okay.
Okay, good. So they can hear us. The hard part's done. I did my part. Now, I'm so happy you're here because, well, first of all, it's been a while. I haven't seen you in. Well, we saw each other, I think, at at Java 1 last year.
Yes, we met at Java 1. I remember that.
But that was in the Java champion thing. I mean, there's like a roundup or something. I don't know. It was a
there was quite a lot of people at Java 1, and it was nice to be to meet all the people in the community.
Yeah, great show. I missed Java 1 because
that would be so great to have the Java 1 we used to have like 10 years ago. But
I'll take any version of it. Any Java 1 is good to me.
Things have changed.
Yeah, well, it was still very beautiful because you were there. All these people that we know, and I as I get when I first started in the community, I felt like I did not belong here. Like I was invading somebody else's party, like they were going to find me and kick me out of the party. And now I still feel like that, but nobody kicks me out, And so every time I get a little thrill every time I see people that like you. And yesterday we did at the speakers dinner.
Yeah.
All these amazing people that we are lucky to have known for so long,
Absolutely.
And I just feel so grateful. I feel.
But I guess it's the same for everybody. I mean,
yeah, but
that's what's wonderful with this community of people is that it's super welcoming, super inclusive.
Yeah.
I mean, anybody is relevant there.
Yeah.
There are top-notch, world-class experts that are coming, and also local speakers, local people, and it's just so great to see that everybody can speak to everybody else, and it's just a bunch of conversations, super interesting conversation.
Very interesting.
Yeah.
And that's the oting is that you get these really smart people that I would have to pay a lot of money to learn from in a regular. If I was just at the office, I wouldn't get your time, right? I wouldn't get smart people like you.
I'm among the very smart people.
I disagree. I think you're one of the very smart ones.
Okay.
And there's a lot of other people like that in the community, including, by the way, our Bob Lee, who passed.
Oh yes.
Yeah. That was another brilliant person in our community that I just felt.
Absolutely.
I always felt like I was lucky to get time with him, to learn from him.
Yes. It's the sad news of today. I mean,
terrible. Yeah. But anyway, I guess what I'm saying is after COVID, I had a lot of trouble. I always felt happy to see people, but before COVID, I always thought, well, I'll have next year to see them again.
Yeah.
Or even later this year, I'll have more chances. And then COVID, and it's now, years not seeing anybody. And there was a time where I was like, maybe I will never see these people again. Maybe the world will become big again. And we'll never, because before it was small. I could get on a plane and be anywhere, anytime.
Yeah.
No matter what. So now here we are at Devnexus. Great show.
Oh yeah.
Huge show.
Is awesome.
Java 1, great show.
Yeah.
Lots of great people, right? I mean, I love that. I love that more than I did before the pandemic.
Maybe we discovered the value of meeting in person because of COVID.
Yeah.
So we did. On the one hand, all these online tools are now really progressed so much.
Yeah.
They are super great, and all these Zoom, Teams, everything.
Right.
Everything is super great, and it's really great to interact with people through that. But meeting in person again
makes it more important.
Absolutely. I think that the more we meet online, the more we realize how valuable it is to actually see people, connect with them.
Also, it makes it so that, okay, you're right, 100%. I also think we have done more to make it so that when we are in person, we don't waste that time. So before, I worked at a company many years ago where we would go to the office, have a meeting at like 9 in the morning for one group of people. It was like a phone call. It was like an hour-long meeting every day. And then we would have 2 hours or an hour, hour and a half. Then 11:30, we'd have the same meeting again, but for a different group of people. Different time zone. So as developers, every day I lost 2 hours on these stupid meetings, these conference calls. It was just a waste of my. Why did I come to work? I'm not writing code. I'm not doing anything. I'm not helping do. I mean, it's just rehashing the story of what happened yesterday. And for some reason, there's 100 people on each of these calls. It was a nightmare.
Okay.
It was a waste of people's time and energy and enthusiasm. It makes it so you didn't want to go to work. And now I think when you get people in the room, as expensive as that is, you don't waste their time with stupid redundant meetings. You want to fully maximize that time with them. So
yeah,
this conference is a great example of that.
Yeah, absolutely. It's a community-driven conference led by the people from the Atlanta Java
Yeah.
U group, and they're just a bunch of
Amazing.
great guys and girls.
Right.
It's just awesome to see how this conference is.
Well, you and I were, yes, 100%. You and I were just talking about how big Devox France.
Yeah.
And
Devox.
Devox in general.
Devox will be next week in Paris.
Paris, and
So
you'll be there.
I'll definitely, yes.
J'y serai aussi. I will also be there. Yeah.
I live like
2 blocks.
not 2 blocks.
Yeah.
Yeah, very close to Paris. So I live in the suburbs of Paris. So yes,
Oh, you're
definitely.
fine.
Absolutely. I wouldn't miss Devox France for anything.
It's a great
And,
event.
yeah,
Thousands of people.
Yeah, and they are. I heard that there are close to 3,000 people attendees,
Wow.
plus the sponsors, plus everybody. So that's going to be a massive event.
Massive.
It's probably one of the biggest, as of now, it's probably one of the 2 biggest conference in the world.
In the world. Yeah.
It's held in French, which is very more
I love it.
bizarre.
Yeah. It's amazing.
It's not even in English. And yes, I think the second, I don't know if it's bigger or not than Devox Belgium, but Devox Belgium is over 5 days, and Devox
Yeah.
is over 3 days.
Devox Belgium is still probably the biggest one,
Yeah.
but definitely the center of gravity. It used to be, you could say, Java, the community
Java
was.
1 and Devox Belgium.
Yeah.
Used to be the 2 most important. Devnexus also used to be
But we
also
also-
very important.
Yeah. But we used to have OzCon here.
Yeah.
And Java 1 used to be much bigger before the pandemic. And
Mhm.
so you could say there's a lot of Java community in America
Yeah.
and a lot in Western Europe. It's all around the world, but the conferences, they seem to be in those places. Now, we have Spring 1, which is very big now. We have
Mhm.
Java 1. Last year was quite nice. And we have DevNexus.
Yeah.
But we don't have OzCon. We don't have, it feels like all the good shows now, most of the good shows are in Western Europe. We've got the DevOxes.
Yeah.
Which is one of them is in Africa. And we've got
It looks like the
big.
faster than in the US.
Oh, yeah.
And
Very true.
now in Europe, things are, I would say, back to what it was before pre-COVID.
Yeah. It feels like this.
It feels like
The
this.
energy. Last year in Belgium
Yeah.
was,
It was just like 5 years ago, 6 years ago.
Yeah.
It was just great.
yeah. And then you've got Java Zone. You've got
Yeah.
JFocus. You've got
JFocus was great also.
GoTo. You've got
Yeah, all the major conferences in Europe.
thousands plus.
But
They're all huge.
Yeah.
So,
absolutely.
yeah. And one of the reasons they're so big is because Java is better than ever. And one of the things it's doing really, really well, one of the things that it's doing really well is innovating. It's delivering new features. One of the big features that I'm really excited about, and coming soon, and I'm hoping maybe you can tell us a little bit about it,
Okay.
is Project Loom, right?
Oh, all right.
Like,
Okay, let's talk about Project Loom.
Loom is
Loom is great.
magic. Yeah.
First thing, Loom
wait.
is great.
Wait, before I actually put it in the title. I
Yeah.
said your name is. I put your name and Java Champion. Tell
Okay.
the audience who you are.
Oh, well, so my name is Jose. I've been around in Java. Well, I started working with Java right at the beginning for several reasons. I'm not that young. That's one of the reasons
Right.
I could do that. And I've been starting to do conferences, etc. But a little more than 10 years ago, I would say maybe 12 or 13 years ago.
Wow.
I was my first experience with the community was the Paris Java user group. I just went to the talk, and I really had such a super experience with this community.
Yeah.
I would really encourage everybody, if you just want to connect with Java people and have technical conversation, find a user group close to your home.
Absolutely.
And if you don't have one, create one. It's not that hard, and it's just so rewarding to do that.
Right.
And I don't Antonio Goncalves. So
Of course,
he's
the
guy.
Paris original one.
Yeah, absolutely. He's the guy who created the Java user group in Paris.
Yeah.
It was the first jug in France, and after 2 years, I think that there were something like 20 plus jugs created following the model of the Paris jug. So it really triggered something.
Yeah.
And that thing became probably bigger than what he first expected.
Yeah.
And this is just great. And this is what jugs are about. You create something and it becomes bigger than what you expect.
And if they do it really well, like I think in France they're pretty connected as well, right?
Yes,
there's a
we
network.
have we have we talk to each other. France is not such a big country,
Right.
so it's easy to meet with people. And so
Not all places do this. I love the model in France. I noticed I can, if I talk to one person, they can connect me with others and make sure I can schedule stuff.
And so we and all these jugs. Well, of course, COVID changed many things for jugs.
Oh yeah, are the jugs back?
Most of the jugs are back. Yes.
Wow,
Sometimes with new people.
Yeah.
With new team, which is great. Which
is
normal and great. And and we'll have a bit of a feather buff session at Devnexus with the jug leaders.
Oh yeah, of course.
Next week.
So is anybody in the, because we have a lot of folks who join us from Europe. I wonder if anybody online, are you planning on going to Devox France or Kotlin Conf? I'm going to Kotlin Conf as well next week.
Okay.
Or just Devox Belgium, anything like,
Well, Devox Belgium would be
November-ish or October.
I think Stefan wants to do it earlier than that.
Right after the summer, maybe?
It was previously it was in November.
Right.
And then he moved it to October this year. And I think he wants to do it like end of September or something.
Okay, so right after the summer.
Yeah, absolutely.
Okay, after the holidays.
Yeah, absolutely.
That's smart.
So
it's always so cold in Antwerp around November. It's so cold.
Yes, but it's part. For me, it used to be part of the mood of Devox.
Oh.
Okay, you bring your big jumper, your big jacket, right? There is snow outside.
He says he hopes to go to. Simon says he hopes to go to Devox. Okay, so we got at least one person we can meet there.
Great.
That'd be wonderful. The cold is my least favorite part. Now they have Uber. So that's one of my least. The other thing was there's no easy way to get around before, and they only take euros in the taxis.
Yes,
but now you can use Uber. Well, no, you can use cards now. During COVID, most things take cards now, and now you can also do Uber in that city as well.
Antwerp is not that big. You can also go around by foot. Take the tram.
Yeah. It's the experience of it was always miserable for me.
Okay.
The people I loved. I love the people, but for me it's always been cold, dark, because the sun sets very early and it rises late.
But when it's cold outside, it's even more pleasant to go in a pub or to go in a restaurant.
True, but then I'm wearing these big jumpers and I'm sweating in the beer cave or whatever. I just I feel always happy every time I go to Devox Belgium. It's weird to say Devox Belgium.
Why?
Because it is Devox Belgium, but it's just Devox.
It used to be Devox, but then Devox France was created, and then the UK, and then Ukraine, and then Morocco, Greece. That is going
Poland.
to for the first time Poland.
Hello, Alexander. Yeah. I agree. I know why. And I'm a Devox champion.
Okay.
Did you know that?
No,
me and Laurent Dogan.
Okay.
We are the only two Devox champions. We spoke at every Devox in 1 year. Right.
In the same year.
In the same year, we spoke at all events for that year. So we did it twice. I did it twice.
Oh, great! Congratulations.
So it's not something you should. I even did Devox US the one time they had it.
Okay.
They had one in California. Do you remember this?
Yes, I do remember. That's going to be harder to talk again at Devox US.
Yeah.
It didn't happen again.
Oh, he said it's slated for 2 to 6 October this year. Okay, so that's good.
2 to 6 October. Okay,
a little bit warmer, not too. And people will still, they'll have, because you don't want to go right after the holidays because people are going to go back to work and they don't have time for more vacation or more fun, So that gives them a month. Okay, good. So Loom is.
So yeah, Loom. After Java 8 and Java 9, the Rocker modules and stuff, many projects have started to be created, and people have started to work on that. And Loom is one of them.
Yeah.
There are other projects like the Ember project for pattern matching, Valhalla for value types, and all these projects. Now that they work so much on this project, they are starting to deliver stuff. First as preview features and incubator features. This is how the JDK is now working, and Loom actually started delivering stuff about a year ago.
Yeah.
First early access, then preview, then incubator features. And right now, so Loom is it's a new concurrent programming model for the JVM, for the Java platform. Concurrent programming is a super easy to understand topic. Everybody loves that.
Right.
My students used to love my course on
right, of course. Yeah.
Because that was by far the easiest one.
Sure. Yeah.
When you have a nice race condition bug in your application.
Oh, no.
This is the kind of bug you prefer to have,
This is the worst.
to have to fix.
And I think everybody has an opinion about it, even if most
Yeah.
people don't do it, right?
Absolutely. But yeah, well, jokes aside,
Yeah.
concurrent programming is a tough topic.
Very.
But it's also super important because it basically runs absolutely everything.
Yeah.
Any kind of web server is built on top of threads and concurrency.
That's the
thing.
That's the even if you're not writing concurrent code, you're using you're part of
Absolutely.
the servlet API.
Yeah.
By definition, you're part of a thread.
Yeah,
or something, right?
exactly. And
know.
if you don't know that, it's probably okay because most of the code doesn't have to take care about that.
Right.
But if you know it and you really understand what you're doing, that's probably better.
Sure.
That's better. So,
Well, even there, I mean, do you remember? I was just mentioning the servlet API, but actually, with the old EJB containers,
Yeah.
there are specific rules. You're not supposed to start your own threads,
absolutely,
right? Because you're participating in somebody else's thread coordination.
exactly.
And you can create issues.
For the EGB, because they are transactional,
Mhm.
the thread that you're running in is actually taking care of the transaction,
Right.
begin and commit for you. So you need to be a little careful if you launch another thread and
Right.
you're not in the transaction anymore.
Right.
You can have big problems.
Big problems.
Yeah.
So
Like the applications are working anymore.
Loom, I think
So, yeah.
we saw the news recently.
So
It's-
there are three parts in Loom. The first part is virtual threads.
Right.
That's a new thread model. The second part is called structured concurrency. That's
Yeah.
an API. But by the way, virtual threads are also an API.
Yeah.
And the third part is the scope values, and that's a model, the new model for
Thread locals.
thread local variables, thread local like variables, I would say.
Okay.
And if there's one idea to remember at Loom is that the virtual threads are not an expensive resource anymore. A virtual thread is a thread. There is a virtual thread class in the JDK that is an extension of thread. So it's everything you can do with the thread, you can do it with a virtual thread, including race conditions and deadlocks and all these kind of good things. And
Is there a Boolean to check if it's a different type? Like, how do I know I'm using a virtual thread?
by checking the class, but your code doesn't need to do that. The API is taking care of that for you.
Right. But if I say current thread, if I say thread.current thread, will I get back current virtual thread or the carrier thread?
No, the current thread, the virtual thread.
Okay.
And you will not see the carrier thread actually. If you break your virtual thread with an exception, you will not see the carrier thread.
Oh, interesting. Oh, magic, but interesting.
Yeah, it starts at this class called continuation.
Right.
This is where the stack trace starts.
Oh, interesting.
So the carrier thread completely hidden.
So the carrier thread is just an operating system
So
task at that point, or do you even have the thing in Java somewhere?
it's so let's go back.
Sorry, yeah.
One step, because I don't know if everybody will understand that. A virtual thread is a thread that is meant to launch to run tasks. All right. It is executed on top of a carrier thread, and it can be unmounted from this carrier thread and kind of backed up in memory when this virtual thread is blocked. So that when you block a virtual thread, actually this virtual thread is removed from the carrier thread to the heap memory. So another virtual thread can use this carrier thread, which is a platform thread, to be executed. So the carrier thread, the platform thread, is actually never blocked. It never blocks. All right. So that's the big thing that Loom brings on the table. And it's completely, it's not new. I was about to say it's completely new. It's new for the Java platform. It's not new because there is one other language that does that, and that has been doing that for years, which is called Erlang.
Yeah.
And that's the only one. There's no other language that is doing that. Go is kind of doing that, but not in the same way.
They have
as
channels
well as
and
Java.
tasks.
They have channels.
Routines.
Yeah, it doesn't work exactly in the same way. Yes, it's different.
I lost it. Wait.
Never mind.
It'll come.
It will come back. Come back.
Okay. Sorry.
So basically, creating a platform thread, it takes about in the order of the milliseconds.
Right.
And you have an allocation of about 20, is it 2 or 20? No, 2 megabytes of memory upfront to store everything you need. So on a regular machine, regular server, you can have several thousands of platform threads.
Wow. Yeah.
Okay.
Wow. Which is so several thousand compared to like a few hundred, maybe if you have enough RAM with regular current threads.
No. Today, current thread, you
Oh.
can have like between 3,000 and 4,000 on a
Okay.
on a 32 gigabytes machine.
Right.
All right. If you multiply the amount of memory by 2, it will be maybe 6,000, 7,000, but that doesn't make much of a difference.
No. Yeah.
Okay. A virtual thread eats up about 1,000 of memory of a platform thread, so it's in the order of the kilobytes rather than megabytes, and it's launched in the order of the microseconds instead of the milliseconds. So you can basically have 1,000 times more virtual threads than you have platform threads.
Wow. So you could get close to 1 million.
You can
easily.
When I'm doing demos, and I'm going to show that tomorrow here, by the way.
Devnexus.
Yeah, Devnexus.
Get on the flight and come here for that talk tomorrow. Right now.
Or watch the YouTube video.
Yeah. Oh yeah. Watch the YouTube video, but also you should come here. It's fun. You can meet him. He's great.
Yes, you can come here. We have to coffee together.
Yeah.
And so you basically can launch easily 1 million threads on a machine in like several seconds, and run them and do stuff with them and block them, and your machine.
Let's talk about that.
It's just okay. Yeah.
That's the question. Blocking.
Yeah.
If I do thread.sleep.
Yeah.
Is that a block?
Yeah.
Okay.
Blocks your thread.
So what if I calculate Fibonacci up to 1 million?
That does not block your virtual thread.
Okay. So what is defined as blocking?
If you have in-memory computations like parallel streams, for instance,
yeah,
running a parallel stream on top of a virtual thread is useless, because there is a virtual thread is running on top of a platform thread, so
right.
There is a little overhead in running your task in a virtual thread, because you need to create this virtual thread. Even if it's not that expensive, it's still an overhead.
Right.
So if you are not leveraging what virtual threads are doing in the right way, in the best way, that is handling blocking in a non-expensive way,
right,
then there is no gain, no benefit you can expect from using virtual threads. If you have parallel streams, just run them on top of platform thread, and that's fine.
Right.
Okay, that's fine. If your machine can do that, then, and if it's what you want to do, do it. Do not use virtual thread for that. You will not gain anything. You will pay the overhead, and you will not get any benefit from
because
using virtual threads.
Is it because they would ultimately be using the same carrier thread?
Yeah.
Anyway,
absolutely.
So they're going to serialize.
Yeah, absolutely. So there's no way. But if you're blocking, then because you have this.
But so what is blocking? Like
blocking, you're just waiting for you're running your task is a HTTP client, and
right.
You're just launching some kind of server request on the web. This server request will take in the order of the millisecond to come back to you.
Sure.
Your JSON document, JSON object will take, I don't know, 10, 20, 100 milliseconds.
Okay.
And your CPU is running in the order of the nanoseconds.
Right.
So you have a factor of 1 million between the time it takes to get this JSON object and the time it takes to actually make it a Java object if you're running a Java application.
Right.
And you don't want to, so your blocking is about that. You can do thread.sleep, but that's for the demos. This is what I use for demos.
So Fibonacci
doesn't block.
Well,
Fibonacci
it takes a long time in the CPU, yeah?
Yes, but your CPU is used during that time.
Okay.
Your CPU, if you check your CPU usage, you see it close to 100%.
Right. That's what you're talking about. You're saying not busy on the CPU, but still sitting in the thread.
If you
not freeing up.
If you're blocking a platform thread because you have an HTTP request that takes 1 millisecond to come back,
right?
Then your CPU is doing nothing, but you still have this thread that is sitting there, eating up megabytes of memory,
right?
Eating up time, and using a core of your processor. So your scheduler will have to move this thread from another core back and forth and check if everything. Okay.
Another thing.
Yeah.
That you just described making a request and getting some bytes back, waiting for the bytes.
Okay.
That's true with today, Java IO input stream, right? If I do while read line, while next byte, get the next byte, not equal -1, that's blocking, right? I'm waiting for the next byte. The next byte might come in a minute.
Yeah.
And my thread is stuck waiting.
Absolutely.
But today I can use the very complicated non-blocking asynchronous IO.
Yeah, absolutely.
Today. Loom fixes this situation.
So Loom fixes the situation because blocking a thread in Loom becomes cheap. Okay, that's the most important thing to understand.
Right.
If you don't get that, then you can't understand the rest.
Okay.
Blocking a thread becomes cheap. So why would you try to avoid blocking a thread if it doesn't cost you that much?
Right.
Okay. Why would you pull virtual threads knowing that actually creating virtual thread is not expensive?
Right.
You don't need to do that.
Right.
You need to pull platform thread because creating a platform thread takes 1 millisecond. So that's a lot. That's a lot of computing time.
Right.
So you need to pull them. You don't want to kill them just to have to recreate them in the next few minutes. All right. So you keep them as a precious resource.
Right.
Now, virtual thread is not a precious resource. So if you need a virtual thread, you just create it. And once you're done with it, you just let it die. And that's it.
So if I do input streams, if I do input stream.read,
yeah,
and it takes 5 milliseconds, does the runtime detect that and move that to the background?
Absolutely. All the Java NIO API has been, hopefully this is what you're using to, to do your IO operations. So all the Java NIO API has been rewritten to leverage that. And
NIO or IO?
NIO.
Okay.
The low-level Java IO API, you shouldn't be using it anymore.
Right.
I mean, the basic writer, the basic
input stream,
reader, writer, input stream. Don't use these classes anymore. When you want to create an input stream, you need to use files.new, input stream, output stream, buffered reader, buffered writer. Okay. And if you check the source code, you will see that it actually creates NIO resources instead of IO resources. All right.
And it's mapped to the interface for input stream and output stream?
Yeah, absolutely. Oh, yeah.
That's new. I don't remember that. That's new to me.
That's from Java.
Files.6
or 7?
No, I know NIO, but there's a files dot.
Yeah, there's a files factory class that has been added a while ago.
Okay.
When really need to check that.
I knew.
And there are factory methods in it to create reader, writers,
Right.
input stream, output stream, and all these implementation are actually built on top of NIO. So these are the ones you should be using.
Okay. What about, but they're mapped to the Java IO input stream and output stream?
Yeah, that's
wow.
Returns an input stream or an output stream.
But and the implementation uses NIO channels and that's cool. Is there a similar thing for sockets? Server socket and socket?
I'm not sure. I'm not really a network guy, so I can't really tell you.
Probably right. Yeah.
Probably, I would say.
So if I use those,
take that. So if you use that, everything is ready.
Nice.
Basically, all right. Everything that you use is already, I would say, Loom friendly.
Yeah.
Loom ready. So if the system detects that you're running in a virtual thread and that your IO operation is blocking, it will trigger this mechanism of backupping the stack of this virtual thread somewhere in the heap memory. And when the signal comes that the data is ready, take this heap memory back to the carrier thread. That's magic. It
is really sorcery.
Yeah.
Wow.
Seen from the outside, it's just incredible.
And the fact that, so Go has something like this.
Yeah.
But they started with it from the very first version. They always had it.
Yeah.
To do what Java is doing 27 plus years later and to add it and make it so backwards compatible. Wow. That's phenomenal.
If you check the pull request of the first merging of Loom in the main JDK branch, it was close to 100,000 modifications in the source code. So guys, if you already made some kind of pull request or how do they call that? Code review for pull request. Right. All right. 100,000 lines modified. Good luck. See you next week.
Too much.
So that was a massive. There are many things that have been changed because of that. All the APIs that needed to be Loom aware have been changed. There are even issues with people that are calling native code, and some of the APIs of the JDK were calling native code, so it has been removed. And there's an example in the method class because the method.invoke class was calling native code. The garbage collectors had to be rewritten also, because when you have some portion of the stack that are actually on the heap, then the garbage collector needs to know that because it needs to check this portion of the stack to do its job. So they have been rewritten and everything. And there's more to come because virtual threads are actually an API. There are going to be more optimization that are going to be done once they are released as a final feature.
Also, okay, so released. They just targeted it. The JEP I saw was updated just a few weeks ago.
Yeah, the JEP was updated a few weeks ago. So I would say that it's on track to be released as the final feature for the JDK 21.
Which is a long-term...
Which is an LTS release. And it's scheduled to be released in September.
Not even 6 months.
No, it's not even 6 months.
Wow.
Not even 6 months. And we will know if it makes it as a final feature probably in June or something, May or June.
Fingers crossed. I know what I want for Christmas. You know, like
All I want for Christmas is virtual
Loom.
threads.
Yeah, it's
that
Loom.
was the song. Oh,
Yeah.
Loom. Yes, you're right.
all I want for Christmas is Loom. Yeah, exactly. Okay. So you've got this thing that is simultaneously very it imposes a significant change onto the code base, and yet for users
It's transparent.
it almost there's some I noticed it like some very small for 99.9% it's transparent. But I know that, for example, if you're doing synchronized blocks around input and output,
So
that's going to be a problem.
the problem is that you need to make sure that this virtual thread can be moved from the platform thread to this heap memory.
Right.
Now, the problem is that Java can call some C code or some assembly code or code written in other languages. Okay. And if in the block that you're calling, that you're moving, you have other languages, and in C, you know that in C you can get addresses on the stack. Right. If you have an int variable declared within a function,
Right.
you can get the address of this I variable, of this int variable, which is not possible in Java.
Right.
So because of that, if you somewhere you have an address on the stack and you move the stack to somewhere else and you move it back somewhere, then your
pointer is no longer valid.
Doomed, because this pointer will no longer be valid. So the solution that has been found is that if in the call stack you have native code, then this virtual thread is pinned to the carrier thread and cannot be moved. So blocking a virtual thread becomes the same as blocking. Will block the carrier thread in the end. So and in the synchronized, but the way the synchronized block has been implemented 25 plus years ago, it's not that there's native code, but there is some kind of native stuff that has been added to store actually the thread waiting on the synchronized block.
Right.
You have 5 thread waiting, they are stored in an array, which is actually an address on the stack.
Okay.
So if you have synchronized block and you want to use Loom, the first thing you need to do is do nothing and see if it's actually a performance issue in your application.
You mean remove the synchronized or leave it there but do nothing?
Do nothing. Just check, is it an issue or not? Because most of the time, if in this synchronized blocks, you're just doing some kind of update of an in-memory variable, of a list, of a map, something, then don't touch it. Just leave it as it is, because it will just go through the synchronized block in several nanoseconds, so you're not going to lose any time. Now, if in this synchronized block you have a blocking operation that will block your thread for several milliseconds, like a network operation or disk operation, then you may consider doing something, because that is going to block your carrier thread, and you don't want that going to avoid.
I see.
You see, so you really need to be very precise and see what this synchronized was doing. And if it's really an issue for your application, then what you can do is replace the synchronized pattern by your lock reentrant lock pattern, which is basically the same. It does the same, but in an API way, and there is not this native stuff that is used, and then your virtual thread will not be pinned on the
So
thread.
The advice that I had heard was avoid doing input and output in a synchronized block, but you just generalized it to actually just anything with JNI is probably an issue. So what about now? This is an interesting thing that I suppose we'll have an answer for later, if not now. What happens when I'm doing Project Panama inside of a
if you're doing JNI, basically you're doing JNI to call some native code.
Right.
All right. In the native, I mean, even if you're not doing it, the JVM cannot know it.
Right.
Okay, and it doesn't want to take the risk to break your application, so it will just be safe.
That's fair.
And pin the virtual thread on the platform side.
Wait, so if what do you mean if you're not doing it?
If you're not using addresses on the stack.
Oh, okay. So anytime you have a JNI dispatch, so you can have JNI in the code base, but as soon as you call an object, if it sees you're going to call an object that has native, public native void, whatever,
it will pin the virtual thread.
Okay.
But that's not necessarily. I mean,
that's a good thing.
The worst case scenario is
Same
that
as before.
you will have the same performance as before.
Yeah.
You will not. It's just that you will not have the benefit of using Loom. in that particular use case. So
most people don't have native code. This is going to be a great. Like I said, it is transparent for 99.99%. You know.
Yeah. So then that's the reason why people are focusing on synchronized block, because synchronized block, you have synchronized block in applications.
Yeah.
Much more than native codes. Absolutely.
So okay, that's like you just upgrade to, hopefully, you know, fingers crossed, we'll keep a thought in your heart. You upgrade to Java 21. Existing code is you might need to change your thread pool to you create a new virtual thread every time instead of
there is an executor service for that.
Yep.
If you check the executors factory class, there is a new
virtual thread pool
virtual thread for each charge to launch blah 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 method.
So but basically, where you could take an executor before, you can now take another. You just swap out the executor. For Spring apps, there's a callbacks for Tomcat and things like that you can use to plug in. So with very little change.
For Spring app, I have that in a demo I did, and I plan to do it tomorrow. There is basically one line of code to write. It works.
Yeah.
Out of the box. That's just amazing. And I mean, Spring is not the only framework that is Loom ready, or at least where people tried Loom and hopefully reported bug when it didn't work and changed their code base if it didn't work. It's the same for Tomcat, it's the same for Elidon, it's the same for Jetty, it's the same for Vertex, it's the same for Quarkus. I mean, all the big frameworks that you're probably using already checked if Loom is working for them. And
well, of course, because the Loom
my guess is that the answer is yes.
The Loom team has been preparing people for half a decade, right? We've been talking about this since before the pandemic. Long time. They've been very good about forecasting. Hey, here's the new build. Here's the new milestone. I mean, smart people.
Publishing early access version.
Very good.
Getting feedback from the community.
This is one of the longer. You know what this reminds me of? You know, remember how many years it took to get lambdas? We had like several different attempts over a decade.
Yeah, Lambda was a different situation because there was the moving of the team from Sun to Oracle, and these were trouble times. So
I'm just saying this one, it's been steady progress from the same team, but because it's so delicate and has to be done so very carefully, and they've done such a great job, it has taken a while, but that's okay because people never felt like they were going to be surprised with a breaking change. It was all very easy to see. So Tom, Spring, you just mentioned there's one line of code. There are some places where you might want to plug in a custom executor. There are callback interfaces, but for we expect that when Loom arrives, we'll have a release of Spring after that just does it by default. Right? It'll plug it in.
Okay.
Or at least it's a property in Spring Boot or whatever.
Normally, when you're doing concurrent programming, there's very little chance that you're interacting with threads directly.
Hopefully,
you're not supposed to do that since Java 5, and that was Java 5, and that was in 2004.
Okay.
All right.
Long time.
The Java util concurrent pattern, you're supposed to use executor services, and if you're doing that, you just need to switch from one executor service to the other, and you don't touch the rest of your code.
Right.
And it should work right out of the box.
This
is something that people can actually try right now.
Yeah.
And
early access already.
Yes, early access, preview versions, whatever. Just give it. If you're in that case, just give it a try and see what it gives.
I have. It's amazing. We actually published. We have people that work on the Tomcat project.
Yeah.
Who are the Spring team. They're part of VMware, right?
Okay.
Not all of Tomcat is part of VMware, but I'm saying we have some people that work on Tomcat. We sponsor them.
Okay.
One of them is Mark Thomas. He just published an amazing blog a few weeks ago saying, look, like, take your existing code, swap out this one little executor.
Yeah.
Your existing Tomcat servlet code, nothing special done to, it's a typical Spring MVC app basically, but it could just be regular servlets. And your performance is now on par. Your scalability, actually, it's not the performance, it's the how many requests I can handle per second. That is now on par. It's at the level you might expect if you were using something like Reactive or Vertex or whatever. So for free, you just upgrade to Java 21 or whatever version it arrives in, hopefully 21, and you get this amazing result. And it's like, it was just such a great blog to see because it's like, it's free. It's free win.
But
Imagine.
that is actually that is what Java is about.
Yeah.
You move from one version of the JVM or from the one version to the API of the API from the other.
Yeah.
And you get free performances. You remember that the string class was wrapping an array of chars.
Really?
Is now wrapping an array of bytes.
Oh, wow.
So because you have so many strings in an application, odds are that you're just decreasing your memory footprint by a factor of, I don't know,
Oh, right.
two that would be a lot, but probably 1.5 or something. And you don't even need to
Nothing
recompile
changed.
your code.
Right. The
Just
interface is
move
the
from one
same.
version to the other, and that's it.
Just the implementation. I love that.
It has been like that for 25
Yeah,
years.
every time. Well, even the just-in-time compiler.
Yeah.
That wasn't in
Just
one
in time
dot.
compiler, Java garbage collector,
One dot one.
everything. Yeah.
Yeah, that was the just-in-time compiler was not there in the first version of Java. So there was a time where you were interpreted and you upgraded and suddenly you get native code for some of it.
Yeah.
For free. You just update. I mean, it just blows my mind, with Go and C and whatever. The performance you get is fast, but it's the only performance you will ever get.
Yeah.
You cannot, you have to recompile the code to get new improvements,
And,
By the way, people, if you're on the line, we're still talking. If you have any questions
oh yes,
with
please.
with this expert, with this, you're an advocate over at Oracle. You're a teacher
I work for Oracle now.
of computer science and
I've been doing that.
Java champion alumnus. Just please, people are saying nice things, but I want to make sure they get a chance to ask.
Oh, it's audio without the cup of coffee. Yes, I'm sorry. This cup of coffee is so precious that I don't travel with it. Thank you, Simon.
Yeah. So I just want to put that out there. Okay, so
Okay.
Loom. So we talked about the virtual threads,
thread part.
which is, to me, that's the free part. Okay.
Yeah.
And that's you take existing code, get a win. There's a new thing.
Yeah.
Which you will get a chance to use, which is the programming model.
Yeah, absolutely.
Can you talk about that?
So absolutely. So there is also a new programming model that comes with it, which is called structured concurrency. Now, structured concurrency is not a new thing neither.
Yeah.
People have been talking about that for years. And the idea is that because virtual threads become cheap to create, so useless to pull, cheap to block, the idea is to stop writing asynchronous code. Okay, so I know that there are many people that are, I love my asynchronous code. Actually, asynchronous code is hard to read,
Very
hard to write. Probably easier. Actually, I'm not very proud. It's probably easier to write than to read, because when you're in your problem and say, okay,
Right.
I need to do this, I need to plug this callback, etc. It's hard to debug. It's hard or next to impossible to unit test, and it's also hard to profile.
right.
When you
Profiling and debugging is a problem.
Yeah,
Big time.
absolutely. But now, are people happy with it? I guess they are, because many people are using it. And is it okay to use it, and do you get good performances out of it? I guess it's the case also, because if it was not, then it wouldn't be a
Well,
thing.
I think you could say you get good performance, and sometimes people are not happy with it, right?
Yeah,
It
of course.
achieved the goals, but at a cost that sometimes people are not willing to pay,
Yeah,
or
exactly.
which they didn't have to.
But I mean, asynchronous programming is a thing as today, so people are using it. Now, the Loom is also bringing a new concurrent programming model that is based on a specific object that is called the structured task scope. Now, maybe this name will change when it makes it in a final release, but that's the main object. And this object is you could see it as some kind of executive service that can accept tasks, returns future, and create virtual thread to execute your tasks. But you can do much more with it, actually, than an executive service. You submit your task, you have a fork method, fork,
Right.
send your task to this stuff. It will create virtual threads on the fly and execute your tasks. You call join will block, but blocking
It's cheap, so
is cheap, so that's
don't need to
okay.
be afraid.
No need to be afraid anymore. All right, and then when you have all your results, you just process your results in a normal way. All right. Now there's a big difference. The actual big difference between an executive service and the scope object. Well, there are several big differences, but the biggest for me is that an executive service holds platform threads. Platform threads are expensive to block. So you create this executive service when your application is launched,
right.
and it stays alive until you shut down your application. So of your application. I don't know if there was a glitch in the
I saw a glitch.
doesn't know. So it actually shares the life cycle of your application, right?
Yeah.
Whereas a structured task scope is created when you need to launch your asynchronous tasks, all right?
Yeah.
And you shut it down when you're done with it. Why? Because it creates virtual threads, and virtual threads are cheap.
Right.
It's always this. It always tends to be the same idea, right?
Yeah.
So it's a very short-lived object. That is, by the way, auto-closable also. So when you close it, you're done with
Oh,
it.
you can do try, parenthesis,
Yeah,
parenthesis.
absolutely. Same
Fantastic.
for executive services, by the way. So executive services have been made auto-closable in the JDK 20.
Okay,
So
great.
that's already a final feature. And that's it. And if structured task scope creates another, if one of the tasks creates another scope object, and then another one, and then another one, all these scopes objects are organized in a tree-like structure,
Yeah.
and they know each other. Okay, so if you shut down one scope object, one structured task scope object, it will automatically shut down. The shutdown will cascade to everything.
Is this what happens to futures if I get a regular future and called .get? Is that
You get
okay?
So you get when you focus task, what you get is a future, and you can use it as a regular future.
Right.
There are new stuff on the future.
Completable future.
You can make it a completable future if you want, but completable future is really for classical asynchronous programming.
Right.
So it's
Don't
really, there's no need to use that in Loom anymore.
Right.
When you get your result, you just process it in an imperative way, right?
But can I call .get?
Yeah,
That blocks, but it's not expensive, right?
That blocks, but it blocks a virtual thread, so that's okay.
Oh, that's what I've always wanted. So I can any method that in Spring you can return a future from lots of different MVC controller handler methods can return a future, and the framework automatically does the right thing there, right?
Yeah.
This just means now people can take advantage of that. Those endpoints can still be used, but now you can call .get yourself, and it's great.
Actually, there are still a lot of discussion about the right pattern to use this structured task scope object. I think the right way to use it is probably not to use futures.
Okay.
Within this object, you have a callback method, and every time a task completes, this callback is called. Within this virtual thread, it's called handle complete. Okay, so complete, like the task is complete. Takes the future as an argument, and then you can just analyze this future and to launch a bunch of I don't know, the classical example I like to take is you want to have quotations for travel, for instance, or for whatever.
Like a cost estimate or something.
Yeah, okay, exactly. And you are querying several servers, and you want to get the best one. Yeah, exactly. Okay. So you just fork every request to every server is its own task. It's runnable or pullable.
Right.
You just fork them, blah blah blah, and then when handle complete is called, you just get the result, accumulate it in some kind of concurrent collection, whatever. And when it's done, when the join method is called and returned, it means that all the future have produced a result. Could be an exception. Then you just take the content of this collection, stream it, get the mean, and that's it.
That's amazing. That's so clean and easy to understand too.
Yeah,
that's what I love.
That makes super. There's no callback in this kind of code.
Right.
Just absolutely no callback.
Get it when you get it.
It's blocking imperative.
Yeah.
So it means that if you want to write unit tests, it's super simple.
Right.
If you want to provide it, we're just providing this. Super simple also.
Right.
And it's all built on top of virtual threads. So that's also, you get also good performances with them.
Wow.
For your overall, of course, if it takes 12 milliseconds to query all your servers, you will not accelerate that. Because it doesn't depend on your code.
It's right? The network night.
Exactly.
Yeah, it's out of your hands.
Exactly. The only thing is that instead of doing like 5 tasks at the same time, like this one, you'll be able to run 5,000 because that's the amount of performances you can expect.
Free. Again, how much does OpenJDK cost? Free. Just amazing. Okay. There's two. So we talked about 3 things that they have. There's the structured concurrency, virtual threads, and
the last one is the scope value, which is a model that is meant to replace thread local variables.
Okay, so why not thread locals?
The first thing that is super important for people to understand is that thread local variables are fully supported by virtual threads.
Mm-hmm.
Thread local variables are working with virtual threads. So if your application is working as you want, don't touch your thread local variables in your application.
Okay.
And don't break your code. You don't need to because it's going to work. It's supposed to work.
Yeah.
If it doesn't, then
That's a bug.
that's a bug. Exactly. So that's the first thing. Now, what's the problem with thread local variables? Problem is that the thread local variables, that's a trick question actually. When I have an audience in front of me, which is not exactly the case here, I like to ask this question. Do you know that there is a remove method on thread local?
Yeah.
And people are just looking at me. Really? So it means that they never create thread locals,
Right.
and then never remove them. So the thread local variables share the life cycle of the thread.
Right.
The thread shares the life cycle of the executor service.
Right.
And your executor service share the life cycle of your application.
Right.
So it means that if you never remove your thread local variables, they will stay there forever.
In the thread, as long as the thread
In
is
the
still
thread,
there.
absolutely. They'll eat up memory and that can be queried by any kind of code.
Right. You
which
can call
is-
that get later on. Yeah.
Exactly. So this is not exactly what you want to do. Right?
No.
That could be called security breach, probably.
Right.
So the idea of scope values, first scope values are immutable, while thread local variables are mutable.
Oh, so you can only set them on initialization?
Exactly.
Okay.
You cannot modify them, which is probably a good thing.
Yeah.
Second, they share the life cycle. They don't share the life cycle of thread, and that's why they are not called thread something. You create a scope variable, and you call a task runnable, which is a runnable,
Right.
maybe a callable, so I'm not sure. Maybe it's only a runnable. And when you launch this task, you say, all right, this scope value will have that value. I bind that value to this scope value.
Okay.
And within the context of this task, you will be able to query for this scope value and get the value that has been bound to it. All right. Whatever the thread you're running in, could be main, could be a virtual thread, could be a platform thread.
Right.
And whatever the method that has been called. So this task is going to call other methods, spawn other threads, spawn structured task scopes, whatever.
Yeah.
As long as you're in the context of this method call, you will be able to query the value bound to this scope value, wherever you are.
Wow.
Okay. So a thread local variable is bound to a thread
Right.
and not bound to any method call, whatever. Okay, whatsoever. A scope value, on the other hand, is bound to a method call, which is a runnable, and not bound to any thread.
But I quite like the idea of having it bound to the method. Actually, that seems because does that mean it gets automatically cleaned up at the end of the method invocation?
Absolutely. Once the method invocation is done, then your scope value is lost.
It's clear. So if I have a method and I set the scope value at the start of the method,
yeah,
but then my method calls another, am I still able to get access to the outermost?
As long as you can access to this scope value stuff.
Right. You have a pointer to the reference itself.
Yes. So it's, if you want to give it access to give the access to from anywhere in your application, maybe it's a public static final stuff.
Yeah.
Okay. So you get the reference to it, called get on it. And if there is a value bound that has been bound for you in the scope value, you will get the value.
Stack method.
Yeah.
Okay.
The value you will have the value.
Amazing. I can't wait. I have some other. I have one other question here.
Sure.
Do you know if there is some project or effort to adapt Java to quantum computing? Don't tell us anything we shouldn't know, but when will we get the Java singularity?
But first thing, I think that quantum computing should be a thing.
Yeah.
For now, I think it's more a research thing, a research project, a set of research projects.
Yeah.
If you want to simulate the way that quantum computing is working, I don't know if there are APIs that are able to do that.
This is C#. Didn't Microsoft release a language, Q# or something like that?
Maybe
that it runs.
I'm not aware of it. I don't know the C# space very well, so I can't tell you that.
Yeah.
But I mean, it's just a matter of simulating. Creating APIs to simulate the way quantum computing is working.
Right. It's very interesting time to be alive.
It is very interesting time to be alive. I never saw any. There are several major breakthroughs that have already been made in quantum computing.
Yeah.
We still need to see applications, what people are going to do with it.
Yeah.
And for that, it needs to work kind of. I mean,
I
don't expect to run Windows on the quantum computer. I don't think that's the goal.
I saw an article the other day that basically said I saw an article the other day that said it was kind of it was a clickbait, but the basic premise is still pretty close to true, which is quantum computing breaks security. You're this security through the safety blanket of SHA or one of these other encodings that becomes we say it would take thousands of years, but quantum it takes
Could
minutes.
make it, could promises to make it in a few milliseconds.
Yeah, very quick, much
Yeah.
quicker than we thought before. And so suddenly this whole field around security based on encryption, all of that looks different now. And I'm like,
Yeah.
oh, that's not good. That's that. Forget the Y2K bug. This is the Q bug or whatever. Q cryptin.
We'll see. We'll see if it's something someday.
Yeah.
Maybe it will. Maybe it will.
I'll just take my Project Loom for now. It's fine. I don't know. The other thing I'm interested in Project Panama.
Okay.
Right. Because I think Java has done an amazing job of making Java as useful as possible for as large and as abundant many use cases as possible. But it is, and it has encouraged people to write Java to get more Java. So if you want to do something in Java, if it doesn't exist in Java, just write more Java. Whereas in other languages, and then by the way, that has promoted write once, run anywhere.
Yeah. Because
most code I write and use in Java is Java. Whereas in other languages, they made it trivial. I suppose it's a bootstrapping problem. They made it trivial to call into native code. So Python, Ruby, C, Go, Rust, all of it. It's a non-issue to talk to native code. And so that means that you can easily install a library that doesn't work on your operating system and those other platforms because it's using native code that only works on Linux or whatever.
Yeah.
So that's not good. I don't want that for Java, but I do think we now, since our ecosystem is mature, I want to be able to talk to some of these other native things. Not all the time, just some on occasion. Imagine what we could do with JavaFX if you could easily integrate with the windowing,
absolutely.
operating system widgets, for example. That's one thing I'm looking forward to, and the other thing is Project Panama and like the matrix vector.
The vector API from
yeah.
the Project Panama. Yeah.
Right, like for highly efficient maths and that kind of stuff. And you look at machine learning, it's become a huge thing over in the Python world because they have things like NumPy and and we've kind of sat in the sideline.
The machine learning is one of the applications that could leverage the vector API.
Yeah.
The vector API from the Panama project has nothing to do with Java util vector.
Right. No.
Which is another super old class. We're not talking about that.
No.
Okay. At the core of your CPU, there is actually I'm not sure how to call that a SIMD kernel. Would it make or SIMD machine within the CPU that is actually not used by the JVM as of now. So the goal of the vector API is actually to leverage the computing power of the SIMD kernel. Now, the SIMD kernel is about computing things in parallel.
Right.
But I mean, not in parallel in a stream API sense, but really, it's like you have several registers with one value in each register, and these registers are connected to their own core. Sorry. We used to call that in French. It was ALU, so it must be UAL in English or something.
I don't know. Probably, yeah.
The logic and arithmetic unit that is actually doing the addition in integers or the FPU for floating point unit. This kind of very low level computing thing. So it has one per set of registers, and you can load everything in one go. Okay.
Yeah.
So if you have 8 such registers, you load 8 integers in one go in this register. And if you want to add one to them in one CPU cycle, you add one to all the 8 registers at the same time.
Right.
So basically, you are gaining a factor of 8 in your computation
Processing capabilities.
without relying on concurrent programming, without relying on any kind of thing like that. So it's really good.
Huge
computing power.
possibilities, right? Like
It's huge possibilities. So the vector API is actually already working. You can
Yeah.
download it, you can play with it. It's an incubator feature of the JDK. So if you downloaded the JDK 20, you have it in the JDK.
and
You
I
can play with it.
so yes, it's interesting, but I think what people are not understanding is that is how we get. For me, to me, maybe nobody from Oracle has told me this. I'm just hoping that the next step after that is okay. Well, we've got the ability to play well with the low level hardware. Let's build something like NumPy, from the Python community for machine learning. And,
You can create NumPy without having this kind of possibility. But if you have that, you will have a NumPy
that's efficient
with amazing performances.
Right. Well, I mean, the abstract NumPy is not just the API, right? It's actually native code.
Yeah.
Yeah, that's what I want to take advantage of. Is that highly efficient processing?
Absolutely.
And they have specialized. This is the other thing. They have separate collections, separate collection types in Python, in NumPy, that are specifically optimized for working with, like, for example, these. And I think with Java, we're so good at keeping the abstraction clean while also swapping out the implementations.
Well, actually, if you activate the vector API in your JVM and you try to do a simple for loop and summing the integers in a for loop, regular for loop, not a vector for loop, you will see that it runs much faster because the C2 compiler can actually leverage the possibility of the vector API to optimize the code on the fly. So that's again free performances.
That's amazing. I am excited. Thank you for
You're welcome.
The free excitement. This is better than coffee.
It's a super exciting time, really. I mean, it's super great to see all these projects that are slowly pushing new features to the JVM to Java platform,
right?
And that bring new.
It's not slow. It's not slow. That's the other thing is all the project Loom has taken a while, but that's because it's huge.
It's huge.
It does amazing things.
Yeah.
But we've gotten so much. Every release has been candy for me.
Yeah.
Something sweet to eat. Every single one, every 6 months. It's not slow. It's amazingly fast.
Yeah. And it's not about being slow. I mean, suppose that in 3 years from now, we have everything that we talked about and we have free stuff and then applications become much more performant and easier to write, test, debug, etc.
Right.
Will people think about, oh, we had it in May 20 or in April or in June? Or
who cares? I got it. That's
do you remember when we had lambdas? Now that we have
14?
Yes, I do.
Yeah.
Also. But I mean,
but
what could be the difference now of having lambdas in 2013 or 2015?
It makes no difference. We'd be the same place by then.
No difference.
Yeah, you're right. 100%. I think people enjoyed your time here.
Thank you so much.
This is a good episode. Look at this. And we got some great comments here.
Okay.
Yeah, it's good to leverage GPU computing. Some libraries exist that do that. Okay, good.
Yeah. Absolutely. But GPU is not on the CPU.
No.
Well, we're talking about the SIMD kernel of the Intel CPU and the AMD CPU.
And we should off stream. I saw a thing the other day that apparently there's Minix. Remember
Minix?
Tannenbaum's operating system? Andrew Tannenbaum, he did. Minix was like the competitor to Linux 30 years ago.
Oh, okay.
MINIX.
Okay.
Apparently Intel has that on the Intel chips.
Really?
Inside the chip.
Wow.
It's running there for other operations. And it's got like, I don't know, it just seemed very like a big thing that you can't patch, you can't see it, you don't even know it's there, but it's running. Okay, so we have let's see. Thank you. Good. I'm glad you got something out of it. Thank you. You're welcome. Thanks for coming. I'm glad you got something out of it.
Thank you, Alexander.
About the new approach in Valhalla. What do you think about that?
Valhalla. So Valhalla is Valhalla is still a work in progress. I'll be also talking about that tomorrow, by the way.
Oh.
And if you can understand French, we'll be doing a 3-hour talk on Valhalla next Wednesday morning at Devnexus with Remy Fox, with my friend Maggie. So Valhalla is going to be probably even bigger than Loom, more complex.
Yeah.
With more impact on performances.
What is it? Just so
the Valhalla is about not having to choose anymore between a good model and good performances. Suppose you are dealing. This is the example I'm going to take. Okay. Suppose you have a bunch of cities, and every city has a population, and you want to sum all the population of all the cities.
Wow.
Right. If you have an array of cities, and city is a record, and within the city record you have a population record that is wrapping an int, you will have crappy performances because you're following one first reference and then a second one, and then you need to unbox the int and to sum it, blah blah blah. It's going to be super slow to do.
Right.
So if you're really in for performances, you say, okay, I'm going to put everything in an array of ints, and then you lose all the readability that a good model brings you.
Right.
Because a good model is about having some kind of readable and understandable code.
Semantically clear.
Exactly. Now Valhalla tell you, okay, this population record is going to be a value record. This city record is going to be a value record, and with some kind of more magic that is going to happen to it, the JVM will be able to inline everything.
Wow.
And basically, when you do the computation of the array, you can. This is. I was working about that just 2 hours ago when
I bothered you.
Yeah, absolutely. No, you didn't. But okay, and you get the same performance when you're summing an array of ints,
right,
or the populations from the city objects.
So behind the scenes, it knows not to like, it can like, it doesn't need to do a dispatch and crawl the reference graph.
Because it's able to inline everything, to flatten all your data, to flatten everything.
Wow.
So if you want to learn more about that, you can download the early access version of the Valhalla project.
So
it's available on JDK. Sorry,
it's a separate build. It's not in JDK.
Yeah, absolutely. It's a separate build.
Okay.
You need to go to the JDK
Yeah.
JDKjava.net, and you have all the JVM available, all the JDKs available with the early access version, and you want to download the early access version of Valhalla. Okay. Wow. You will have a version that has been built back in October or November, I think, maybe December.
6 months already.
It's the LW4 version, and if you're really interested in that, you need to wait for the LW5 version that is not scheduled yet, but that will be published probably in summer, this summer, September, something like that.
The team working on Java I understand they're very busy.
Yeah.
So I'm getting my Christmas gifts early this year with Loom. Hopefully, fingers crossed. Take your time, no stress. Please just do it when you can. But if they can release it before with Java 21, that'd be great.
Yeah.
But and again, do we have any idea on the scope or timeline of Valhalla?
Oh no.
No. Okay.
No
problem. I just want to know. I'm not greedy.
What I'm just telling you is that if you're excited by this project and want to learn more,
sure,
go put your hands on the early access version. I did a video on the project a few weeks or months, or I can't remember when, ago on value objects. I'll probably make another one. We are going to talk more about that because it's a super exciting project. And when Loom made it live as a final feature, we need to find something else to talk about, right? So Valhalla will be probably.
I know you will always have something interesting to talk about.
Thank you.
I love your. I can't type at an angle. You have a wonderful.
Thank you.
Series of videos.
Oh, the Jet Cafe.
I love these. Like this is. Yeah, it's not that old. But you do these.
I try to do it every month.
Yeah.
I'm more on a 10 episode per year.
That's fine. Take the summer off.
And I just released the 18th episode, and it's on the Vector API precisely. So if you're interested in the Vector API,
that
you may want to watch the last episode.
The JEP Cafe, JEP Cafe. If you want to Google it,
it's a play on word because the JEP is the Java Enhancement Proposal.
Right.
That's it.
Right. I love it, and this has been so valuable.
Oh, thank you.
It's clear you're a teacher. And
yes, I did that for basically all my life.
You're magnificent, really. It is a privilege to get free education from you.
Oh,
and I think these are worth people's time. JEP Cafe.
And I'm not doing, but maybe doing some live streaming is something that I should be working on.
Yeah,
I
well,
should work on in the future.
we're doing it now.
We are doing it now.
Nobody's
absolutely.
dying.
Yeah.
Like, it's fine, right? We're okay. Let's do more.
Maybe we don't know.
Oh yeah.
Okay.
Of boredom from me, maybe. No, you are really Jeb Cafe. Are you on Twitter? You said you're on Twitter.
Yes, José Paumard is my Twitter handle.
So Jose underscore?
No
No underscore. So
Underscore.
Jose.
PAU, but they just Google my name on Twitter. You
Well, spell it so they can Google it.
José, Josepamard.
Okay, thank you.
That's a French word name. So yeah.
So this is going to be in the podcast, and people won't have any visuals. They'll just they'll have the show notes and whatever. But
Okay.
I just want people to find you.
And if people are really very good at Googling stuff, they can also find a series I created just a few months ago, which is called the Cracking the Java Coding Interview.
Oh,
already 42 episodes.
I would like.
It's a series of shorts on YouTube, and the gist is that I take some kind of frequently asked question for in Java coding interviews, and I try to provide yes, that's the one.
This one?
At the bottom.
Here.
So short video are 1 minute into videos. That one.
This.
And so there are 42 plus of them. And if
Fantastic. Look at that.
if you're interested in that, well, if you're already a seasoned Java developer, you probably don't learn much. Well, maybe you will.
I will.
Maybe you will learn one thing or two. In all the stuff that I did, and that's that's the last thing last new thing I've been doing. And there are 2 episodes every week that are published. I think it's the Wednesday and Friday. I need to ensure.
I will watch those.
So these are shorts. It's just 1 minute. So in 1 minute you don't have much time to.
But so here's the thing. Don't tell anybody,
Hmm?
but I don't know if I could get a job doing Java anymore. Right? Like I know how to write Java a little bit, but I feel like I'm no longer optimized for the interview.
Oh, I see what you mean.
You know what I'm saying?
Yeah.
Like, and it takes somebody who's very smart to keep that skill top of mind, because it's not the same, right? I know you can write production code.
Yeah.
But
well, I guess so.
well, of course, obviously, but I mean, but to keep these interview questions, to keep those and to understand what people are looking for in those answers, that's a skill, and I haven't needed it in more than a decade, right? Because I've been please, I hope this doesn't change, but I'm happily employed.
Okay.
Gainfully employed, unless VMware has some news for me that I won't like, So this is the kind of stuff where it's very good. It keeps your mind fresh.
And it's also super funny to make. So
oh, good.
As long as I have fun doing that, I will continue doing that.
During the pandemic, Monsieur Paumard has produced in French many courses to explain the Java and the APIs from the beginning.
Yes, I also have a French YouTube channel.
José Paumard en français?
Oui, absolutely. José Paumard en français.
Okay.
With the courses I've been given at the university for basically 25 years. So there are something like 80 hours of videos, but it's in French, right? So
yeah, there's a billion people or more that speak French. So
a billion people, that may be a lot, but
where? Okay, is it the same? Is it this one? Same channel?
No, it's another channel.
Okay.
If you go there, I'm not even sure it's linked to this one, to be honest.
You should what is the name of it?
The name is Cours en ligne, which
Cours
en ligne, maybe Cours en ligne.
Like that?
Can you use the search engine if you want to find it?
Google has a search engine?
YouTube has a search engine.
Oh, okay.
Google, I don't know. YouTube, I know it has.
Oh, voila.
That's the one.
Okay, I'm gonna pay. This is
right. So
yeah,
100% French content, and there are 80 hours of Java online courses that you can follow. But these are really university lectures, right? So
yeah.
So it's not necessarily for seasoned developers, mostly for beginners.
But that's the thing. This is valuable, super valuable.
Okay.
People would pay. I mean, they do. Obviously, they pay to go to
Some of
university.
them pay, but
Yeah.
that's on YouTube, so that's free.
That's what I'm saying. You're giving away very valuable knowledge, and I appreciate it.
Of course. Hey, the Java community is about sharing, right? So it's
Oh, yeah.
all about sharing.
But I mean, I share. It doesn't mean it's any good. Like there's the difference, man. You know, like I really appreciate what you're doing. I appreciate you.
Thank you so much.
Everybody who's stuck around, you are lucky. You got one of the best people. He's going to give 2 talks about this at Devnexus.
Tomorrow.
And you know, you should be here. You should be watching that presentation because we don't have enough time to cover everything.
Yeah.
But for those of you who joined in, you got a good taste of the future, and I appreciate it. Thank you for your time.
Thank you so much, Josh. Thanks to all the people who followed us. Hopefully they also had coffee at the same time, so that
Yeah, coffee and software. I finished my coffee before we started talking, but I was drinking a coffee when we met.
yeah, absolutely.
Yeah, okay.
We were having coffee.
Bye, everybody.
Bye, everybody. Thank you for watching.